Hello, Surfactant and all the rest of you good people out there. I hope that you are all safe and sound and that health is with you and that you are staying healthy. Regarding your question on the forum on how to fix a bridge curve to G1, G2 while keeping the deviation small. With the given data, it is a little bit difficult to maybe kind of propose a good solution. So since I do not know where these curves come from, I do not know where they're going, I have to do a bit of assumptions here, so that is what I do. Looking at the curves on the screen, we can see that we have two blue curves and we have some sort of transitional curve in between named blend. We can also see that we have some sort of issue from a curve transitional analyze in the start and in the beginning. Now, if I throw some curvature combs on this, we can see that the issue reflects in the curvature combs as well. Now, with the given prerequisites, I will actually focus on that curvature comb because it makes it a little bit easier to kind of explain what's going on. So let's get rid of those poles, but before we start, we're gonna get some more information on what that curve is. It's a spline curve. It's degree 5, have 6 segments. Now, with 6 segments, 5-degree spline, I need 6 points to recreate that thing. And that is actually what I'm gonna do. So I'm gonna recreate this thing. There are obviously several ways of doing this, but this would be one way. So I would create a point set on top of that curve with 6 points. So I'm going to have a degree 5, 6 segments. And we say OK to that. And then I'm going to create a fit spline to that. I'm going to create a fit spline degree 5. And I'm going to use chain points. And I'm going to use the points I just created. So we have a start and finish here. Let's hide that transitional so we do not cover the two. Now in this end here, we know that we want that not to the point, we actually want it to the end point of that curve, and we want to add a G2 continuity to that. I assume that G2 was important here. We're going to do the same on the other end. We're going to add G2 continuity there as well. Now I could be happy with that, and I could say that, well, yeah, that looks good, but if we add those curvature combs to this, we will see a somewhat wobbly curvature comb here. We do fulfill the transitional areas here, but I would assume that these undulations along this curve would be undesired. At least they would be to me. So what can we do? Well, to fix the problem here, or fix what I want, I'm going to play around with the tolerance here. I still want to keep it at degree 5, but I'm going to allow it for some freedoms around those points. Let's start with 1 and see what happens. Say OK to that, and not much happened. So let's do that again and give it a little bit more freedom. Let's say 2. Well, now the comb starts to look a little bit what I want. So I need to release a little bit from the points. Now, the curve fit here and the tolerance doesn't mean that it's going to deviate 2 millimeter from every point. It's going to find the kind of golden middle way, if you like. It's going to find the curve where it satisfies the best possible tolerance around every point, but is allowed to deviate at 2 millimeters. So here we have created some sort of transitional curve with least tension, kind of forming a nice curvature comb, and I'm going to be happy with that. Just to verify, let's turn off the old analyze and let's hit the new one. So curve continuity, let's see. Well, and that is pretty good to me. I'm quite happy with that. So green is good. Now that would be one way of doing it, and I would assume that the curvature comb would be of essence to you. And with the given prerequisites, well, this is probably the way I would do it. So with that, I'm going to leave you. I hope that all you people are staying safe and sound and staying healthy. So over and out from Fred. Take care for now. Bye bye.